Alright guys, so how's your understanding on chapter 3 so far? Okay, I hope you are getting better and can grab the knowledge of integration process much better than before. Okay, now we are going to learn subchapter 3.4, which is integration of hyperbolic function. In this subchapter, okay, if you have mastered the previous techniques that we have learned, which is integration by substitution, by parts, by tabular method, and by partial fractions, you are going to see that the question for integration of hyperbolic function will be much easier to be done, okay, to be calculated. And sometimes you may need to solve the questions by using hyperbolic identities. So this is quite similar with the trigonometry function. Okay, it's just that hyperbolic identities have a slightly different notation here. Okay. For example, here for trigonometry identities, okay, we will have sine squared x plus cos squared x equals to 1. But for hyperbolic identities, it is hyperbolic cos squared x minus hyperbolic sine squared x equals to 1. Okay, but don't get too worry about, because these identities will be given during final examination. Okay, now before we can look into examples, okay, 3.34, 3.37 and 3.39, here are the indefinite integrals for hyperbolic functions. So if you integrate hyperbolic cos, you will get hyperbolic sine. If you integrate hyperbolic sine, you will get hyperbolic cos. Okay, since this is indefinite integrals, so each of these will have plus c. Okay, now I would like to mention about the difference between hyperbolic function and trigonometry function when you integrate it. So in trigonometry function, if you integrate sine, you will get negative cos. But here in hyperbolic function, if you integrate hyperbolic sine, you'll get hyperbolic cos. And another thing that is differ is here, hyperbolic secant, hyperbolic tangent. Okay, if you integrate it, you will get a negative secant, hyperbolic secant, negative hyperbolic secant. In trigonometry function, you will get positive here. So that is the only difference. Okay, now let's check it out. Examples of hyperbolic function. Okay, we start with example 3.34. Okay, this is very simple. Evaluate hyperbolic sine 2x dx. So the solution is that you need to just straight away integrate this by half. Okay, so sine hyperbolic, you will get hyperbolic cos. Alright, so half hyperbolic cos 2x plus c. Now example 3.35, evaluate hyperbolic sine squared x dx. So here we have the power of 2, so we can use the identity. You can refer to the hyperbolic identity table. Okay, so the easiest is by using hyperbolic cos 2x, okay, is equals to 1 plus 2 sine hyperbolic squared x. Okay, so we'll bring 1 over here. So here we have, it will become cos hyperbolic 2x minus 1. Okay, and as for 2 here, since it is multiplied with hyperbolic sign, so we can bring it over here too. It will become half. So you can straight away integrate this one. So it will become half hyperbolic sine 2x. You integrate 1, you will get x. Okay, and this can be your final answer. Or if you want to further simplify it, okay, it will become like this. Yeah. Okay, now example 3.37, evaluate hyperbolic cos squared 2x dx. So again, since we have power of 2, we need to use the identity. So this is the similar to the previous example 3.35. So here we use cos hyperbolic 2x equals to 2 cos hyperbolic squared x minus 1. Okay, this is the original hyperbolic identity. But okay, since we have here, okay, in the original question is 2x, you need to remember that you need to double up. Okay, let me write it down here. Okay, so this is the original one. Okay, cos 2x equals to 2 cos squared x minus 1. Okay, but our question here, we have cos squared 2x. We have 2 here. Okay, the original one only have single x. Okay, so what you need to do is that you need to tackle the trigonometry identity here by making sure that this one has the 2, okay, 2 times x, so that this one also times 2. So your new trigonometry your new hyperbolic identity is hyperbolic cos or cos 4x equals to, okay, this one remain the same, yeah, this one remain the same, 2, okay, cos squared 2x minus 1. Okay, since we are interested to get this one, so you just need to rearrange it. Cos 2x equals to half, so this one bring over the 2 here, bring it over here, so you'll get cos 4x, okay, plus 1. So you bring plus 1 first, okay, you bring plus 1 first, only then you bring the 2 here. Okay, so it will become like this. So this is, okay, what happened here, what is stated here, half, integrate half cos 4x plus 1. Okay, next just proceed as usual the integration process, and this will be your final answer. Okay, either one. Okay, and the last example that we're going to discuss is example 3.39. You need to evaluate x squared hyperbolic sine 3x dx. So this is using the tabular method. The question asks you to use tabular method. Just recall the tabular method process that we have learned before. Start the sign with positive, followed by negative, and then you repeat with positive and negative and so on. Okay, and it depends on what happened here. Okay, the derivatives of u and integrals of dv. Since this is the algebra function times up with trigonometry function, okay, so you need to remember that we pick the algebra to be as the u, so we differentiate it until we get 0. Once you get 0, we stop here and we can proceed with the integrals of dv, which is hyperbolic sine 3x. So you straight away integrate it until the last row here must match with the 0 here, 0 at the derivatives of u. Once you done that, you just multiply it in diagonal direction. So for example, here we get 1/3 cos 3x times x squared minus, so you need to refer to the minus sign, minus 2/9. This one is missing x here. Let me write down it for you. You can do the correction here. So it should be 2/9x. You bring the x here in your final answer. Don't forget about it. So this is a typo, just a typo. 2/9x hyperbolic sine 3x plus 2/27 cos 3x plus c. So because this one, you cannot do anything, it is just 0. So we just stop right here. Is that clear? So try to do other examples in these hyperbolic functions so that you will master the techniques of integration. Alright guys, so stay tuned for my next video.